Because it has anomalies. It moves on a trajectory that is very unusual, is aligned with the orbit of the Earth around the Sun, and it will get extremely close to the inner planets like for example, Jupiter, Mars, or Venus. It will arrive closest to the Sun when the Earth is on the opposite side, so we won't be able to look at it. You know, the chance of this trajectory is less than 0.2% to be aligned with the orbit of the Earth around the Sun, less than 1 part in 20,000 to arrive so close to the other planets. And one wonders, could it be a design trajectory?
The solar system recently got a surprise visitor, and this one's an absolute giant. Named 3 Atlas, it's the third confirmed interstellar object ever discovered, and its orbit proves it's just passing through. With an eccentricity higher than 1, Atlas isn't staying. It's blasting through our solar system once before vanishing back into interstellar space forever. Images from the Vera C. Rubin Observatory show 3 Atlas stretches nearly 7 miles wide, making it the largest interstellar object ever found. It completely overshadows Borisov, which was barely half a mile across, and Oumuamua, just a fraction of that. But what's inside this monster is even crazier. Scientists discovered it's loaded with water ice and carbon-rich materials, the same building blocks that formed planets like Earth. NASA's Infrared Telescope and Gemini South Observatory confirmed that the water within Atlas is chemically pure, untouched by the heavier isotopes seen in comets from our own system. That means it likely froze over 7 billion years ago before Earth was even born.
Unusual fact about its trajectory is that it comes very close to the inner planets other than Earth, like Jupiter, Mars, or Venus. And the chance of that happening, given the trajectory, one can change the arrival time of this object, and only in 1 in 20,000 cases you end up with such a close proximity to the planets, because they orbit around the Sun, and the chance of being so close to them is very small.
This thing is a frozen fossil, a time capsule from another star's nursery carrying the history of a distant solar system. These discoveries suggest 3 Atlas might just be a comet, but not everyone's buying it. It's slicing through space at a wild 130,000 miles per hour, moving backward on a steep retrograde orbit opposite our planets. Astronomers have been tracking it closely.
It's irresponsible science. This is just coincidence, the path that it comes through the solar system. There's a perfectly natural explanation for this. It is behaving like a regular comet, and a comet is just one of these primordial building blocks of planets made of dust and ice, and when it gets closer to the sun, the sunlight warms up the ice, and then it goes directly from a solid to a gas and pushes the dust off. So this looks just like a normal comet.
Marking major milestones in its cosmic journey. October 3rd, 2025, Mars flyby already happened. Just days ago, 3 Atlas made its closest approach to Mars. At sunrise over Valles Marineris, the red planet witnessed the comet sweep past at only 18 million miles away. NASA's MAVEN and China's Tianwen-1 orbiters captured incredible data as its coma, that glowing dust halo, turned faintly pink under the Martian dawn. Those readings are still being analyzed, but early reports show wild changes in temperature and brightness. October 29, 2025, perihelion incoming. In just weeks, 3 Atlas will swing behind the Sun, skimming to 1.36 astronomical units, or about 130 million miles from its surface. Its speed will spike to a staggering 152,000 miles per hour. Earth-based telescopes won't see it. It'll be hidden in solar glare. But spacecraft near Mars and the L1 point will stay locked on, watching as powerful vapor jets burst from its heated crust. December 19, 2025, Earth distance check. When it returns to view, Atlas will pass by at around 170 million miles from Earth. Too distant for the naked eye, but perfect for the James Webb and Rubin observatories to study its tail and hunt for chemical fingerprints never seen before. March 16, 2026, Jupiter encounter. The journey continues. Atlas will swing just 33 million miles above Jupiter's clouds, and if NASA approves a maneuver, the Juno spacecraft might even adjust its orbit to sample the comet's dust, offering a direct taste of material from outside our solar system. After that, 3 Atlas will disappear back into the darkness, leaving behind terabytes of data and one massive mystery. Because some scientists aren't convinced this is just a comet, they think something deeper might be hiding beneath that icy shell. Harvard's Avi Loeb, the same astrophysicist who once claimed Oumuamua could be an alien probe, is back and stirring up debate again. His new paper is the Interstellar Object 3I Atlas Alien Technology. Suggests this colossal object could easily hide advanced instruments inside. He even references the dark forest hypothesis, where civilizations conceal themselves to survive cosmic predators. Loeb hints Atlas might be a stealth probe quietly observing or scanning our solar system. He argues that its bizarre retrograde orbit and extreme speed could be deliberate. Signs of design, not coincidence. Even more suspicious, its route brushed past Venus, Mars, and Jupiter in near-perfect alignment, a path too precise to ignore. He reminds everyone that humans have already done the same. The Voyager and Pioneer probes have left the solar system, carrying Earth's data into the unknown. So, if we can send messages to the stars, why couldn't someone else send one here? And there's another eerie twist. Loeb says 3, Ice Atlas's closest pass, happens behind the sun.
From images, we also saw that this object is active, which means that around the nucleus there is some coma, which is an indication that this object is in fact a comet.
Perfectly hidden from Earth's view. That could allow it to deploy something without being detected. Based on its speed, Loeb estimates it entered our system roughly 8,000 years ago. Around the same time, humans first began recording history. Other scientists push back though. They note that Atlas still doesn't show the usual signs of a comet. No cyanogen or diatomic carbon gases glowing in its coma. Its behavior remains puzzling. So the question lingers, is 3 Ice Atlas just a natural wanderer or alien technology cloaked as cosmic ice? Experts keep saying no, but the evidence keeps whispering maybe. Ever since 3 Ice Atlas was first spotted, astronomers have been collecting data non-stop, and most of it still points to something pretty ordinary, a comet. The images and spectra reveal dust jets and a faint, hazy coma, exactly what you'd expect when sunlight starts warming an icy nucleus. As for the missing gases like cyanogen or diatomic carbon, the ones that make comets glow near the sun, it's just too early. 3 Ice Atlas is still way out in the cold, and most comets don't start showing those telltale gases until they dive deep into the inner solar system. Over the next few months, once the heat kicks in, astronomers expect those glowing emissions to appear, if Atlas truly is what it seems. That's already one big difference between Atlas and Oumuamua, which never released any gas at all. In fact, Atlas acts a lot more like Borisov, a comet that behaved exactly as physics predicted. But that raises an eerie question. If Atlas and Borisov are following familiar patterns, then what on earth was Oumuamua? Why did it break all the rules and slip by unnoticed until it was already leaving our solar system? Let's rewind to October 19th, 2017. The Pan-STARRS. One telescope in Hawaii was scanning the night sky when, at 1:22 a.m. Hawaiian time, a strange streak flashed across the frame, moving way faster than any asteroid should. Hours later, at the University of Hawaii's data center, astronomer Robert Warwick spotted that faint streak and realized something was off. The object was zooming in at 26 kilometers per second, and its orbital eccentricity, 1.20, meant it wasn't staying. It was on an escape route. Within 24 hours, the object got its first name, C2017U1, assuming it was a comet. But the next day, new images showed no tail, no coma, no gas, nothing. So the C was dropped, replaced with an A, turning it into A2017U1. Even that didn't fit. The object didn't behave like a comet or an asteroid. So the International Astronomical Union created a brand new category, I for Interstellar, the first of its kind, 1 Ice Oumuamua, which means scout in Hawaiian. Astronomers suddenly realized the window to study it was closing fast. It was fading beyond the 24th magnitude, and they only had 40 days before it vanished forever. The mysterious object had swooped in from the direction of the bright star Vega in the constellation Lyra, the same area our solar system drifts toward. It passed incredibly close, inside Mercury's orbit, only 38 million kilometers from the sun, before slingshotting away toward Pegasus, never to return. Tracing that path backward was hopeless. After millions of years drifting through the galaxy, gravity from passing stars and tidal forces blurred its original trail. The best guess? Long ago, in some distant planetary system, a giant planet might have flung it out into space, leaving it to wander for eons until it crossed paths with us in 2017. But here's where it gets truly strange. Observations from telescopes worldwide showed Oumuamua's light fluctuated wildly every 7.3 hours, brightening tenfold, then dimming again. That kind of pattern meant the object was tumbling, either extremely long like a cigar or pancake flat like a saucer seen edge on. And since no telescope ever resolved its actual shape, both possibilities are still on the table. Then came the shock of all shocks. The European Space Agency discovered that after passing one astronomical unit from the Sun, Oumuamua suddenly accelerated, ever so slightly, by about 5 millionths of a meter per second squared, but enough to stand out in every dataset. Normally, that kind of boost means comet-like jets pushing it forward. But there were no jets, no dust, no vapor, nothing. Solar radiation alone shouldn't have done it either, unless the object had an enormous surface area compared to its mass, like a paper-thin sheet hundreds of meters wide. No natural object like that has ever been seen. So what were we really looking at? To find out, NASA turned the Spitzer Space Telescope on it for 30 straight hours. Spitzer can easily spot the warm glow of comets even millions of miles away, but on Oumuamua, it detected absolutely nothing. No heat, no dust, no emissions. The mystery deepened. Even more shocking, the data showed that Oumuamua's surface reflected 10 times more light than the carbon dark crusts of typical comets. That level of brightness hinted at something metallic, something engineered. By late 2018, Harvard's Avi Loeb and his team published a paper in the Astrophysical journal Letters and dropped a bombshell. If no natural process could explain it, maybe it wasn't natural at all. Loeb proposed that Oumuamua could have been a light sail, a piece of alien spacecraft perhaps, abandoned or derelict, drifting between the stars. That theory set the world on fire. Headlines exploded, scientists debated, and people everywhere started asking, had humanity just been visited for the first time? Some called it open-minded science. Others said it was pure sensationalism. But one thing was clear. Oumuamua changed how we look at everything that enters our cosmic neighborhood. Two scientists, Daryl Seligman and Jennifer Bergner, decided to challenge Avi Loeb's wild theory with something far more grounded. They proposed a fascinating idea. When chunks of water ice sit in deep space, just a few degrees above absolute zero, cosmic rays slowly break apart hydrogen molecules and trap them inside the ice. Over millions of years, those frozen fragments become ticking hydrogen reservoirs. When such a chunk swings close to a star and heats above 40 Kelvin, that hidden hydrogen escapes as invisible jets. These tiny gas leaks can push the object forward, creating motion without visible dust, carbon dioxide, or any heat signature for infrared telescopes to detect. They called these stealthy travelers dark comets. This dark comet theory explains Oumuamua's mysterious acceleration and spotless trail without invoking alien technology. And it didn't stay a theory for long. Astronomers have since found an entire family of these invisible pushers within our own solar system. Each one shows subtle outward thrusts but no visible gas or debris. Exactly what Seligman and Bergner predicted. So, yes, what started as a hypothesis has become a recognized class of small bodies. Cosmic ghosts that move without a trace. But not everyone's convinced. Avi Loeb remains the loudest skeptic. In new essays and follow-up studies, he argues that the hydrogen ice theory doesn't hold up, claiming it miscalculates how the surface cools when gas escapes. He insists that even hidden hydrogen would still leave detectable marks. And since none were found, Oumuamua's boost must have come from something else. Maybe even light sail technology powered by radiation pressure. He's not letting this one go. So how do we finally settle this interstellar mystery? That's where Project Lyra comes in. A bold blueprint from the Interstellar Probe Working Group aims to go after Oumuamua itself. The plan? Launch a small spacecraft, possibly aboard a Falcon Heavy or Starship around 2028, swing by Jupiter for a massive gravity boost, then dive close to the Sun for an Oberth burn. using solar gravity as a cosmic slingshot to reach speeds of 20 to 25 astronomical units per year. If everything works, that probe could actually catch up with Oumuamua, but not until the 2050s, when it'll be more than 200 astronomical units away, dimmer than magnitude 35 and harder to spot than anything humanity has ever tracked. Pulling this off would require heat shields tough enough to survive the sun's fury and propulsion systems faster than anything we've ever built. It's a long shot, literally, but maybe there's another way. Instead of chasing what's already gone, scientists might get ready for the next interstellar visitor, and this time, we're already watching. While Oumuamua broke every rule, no tail, no heat, no gas, 3 ice Atlas seems to fit the comet pattern perfectly, and that makes it crucial. By comparing these two cosmic outsiders, astronomers might finally learn what's truly normal and what's utterly alien. If you're loving these cosmic mysteries, hit that like button, subscribe to the channel, and stay tuned, because the next interstellar encounter could change everything we know about our universe. See you on the next one.